recap from yesterday. Yes. Of course. Don't need to write this, but it's a recap from yesterday. Combine like terms, what do you get? Correct. And again, just to kind of put it back into your head, how would you test to see that this expression g times g times g is equivalent to the expression g cubed? How would you test it? What did I tell you to do? Who remembers? Maths. Right, give g a value. Give g a value. Not 1 though, because sometimes 1 can throw you a curveball. You're going to go a little higher? Alright, we'll do 5. Substitute it in. And I think that you can see without actually evaluating it, it really is the same thing, right? What do you get, by the way? You get 125, but don't call out. Okay? So that's what you're going to do, is every time you create an expression that you're not quite sure of, you can always test it by swapping out the letter for a number that you can choose. You can always choose low, because you don't want to do crazy math in your head. Here we go. What do you think? First, let me ask you this. Is this g plus g plus g the same as g to the 3rd power? So why don't we do this? Before you raise your hand, mentally substitute a letter or a number for g. Add it. And see if then you can create what you think the combined like terms would be. Go ahead, Nick. I'm going to give you a shot. I'm going to give you an opportunity to just take a look at it and start throwing out some ideas. Because they can be combined. This can't be combined as g cubed. It won't work. Angelina. Might as well. How do you express a coefficient and a variable together? How do you express a coefficient and a variable together? So far, you get a half a snow cone.
Need to put what coefficient and then.
Okay? So remember, the coefficient always has to go before the variable. So you have the idea down, you just didn't quite say it right. Are you okay with understanding why I just took what you said and made it 3g rather than g3? Okay? Because if you put it as g3, it looks like an exponent, so we don't write it that way. How do you test to see if it will work? Come on, more hands. How do you test to see if any two equivalent expressions are the same? What do you do, May? Give me a variable. Give me a number for a letter. All right, we'll do 2. Evaluate it. What do you get? Ready? 3 times. What do you get? Looks like it's going to work, right? Do yourself a favor too, especially with this. Do one more other number for a letter to totally be convinced that it will work. Aiden, give me another number for a variable. We'll do it mentally. What's 4 plus 4 plus 4?
12.
What's 3 times 4?
12.
It works. Okay? That's the gist of the second part of combining like terms in less than 6. Now you can open up your book, so I think it's page 80. The only difference between the warm-up that we just did and the examples, they just want you to substitute rather than 3 is to substitute 4. So we're going to take the 4 and we're going to put it in each time for the x's. We'll kind of go through this quickly because we've already done it. What do you get as an answer? 12. All right. What's supposed to be an equivalent expression, we're going to see if it works. 3 times what? Which is and we're going to kind of just put it into words. Let me ask you to think. How do you put this into words? What do you notice about the answers of part A and B? Well, we know that they're equal. They're identical. What you can conclude about combining like terms, how do you put it into words? How do you combine like terms with addition? Think about what you did. You had an x plus an x plus an x. And you had 3x. Can you put that into words? What you did? Let's just all over this, like, maybe. That's a solid hint right there.
Stop with it.
Alright, so we're kind of getting there. Like, let's see if we can figure out maybe a rule or a pattern, if you will, on what you notice. Coach, go ahead. Okay? Yes, it's in essence, she's got it. The amount of times the variable repeats in addition is the number you multiply by. So you got x plus x plus x. How many x's? How many times did it repeat? 3. 3 times, and what variable got repeated? 3x. X plus x plus x is the same as 3x. Makes sense? What about, listen carefully, n plus n plus n plus n plus n plus n? If you're smart, let's get back there. Every time we mention a letter, keep a little count. Instead, you listen carefully. What do you get? No. See? Did I say it's 6 to do with 5? I don't even know. I thought I said 5. Okay, so I repeated the n 6 times. And so therefore, the equivalent expression is 6n. All right, so let's get back to this and put it into words. Answering the first part, the answers are the same. That we know. And then the rule that Sophia came up with. I'll try to make this as simple as I can. The number of times the variable repeats becomes the, and if you raise your hand and you fill in the blank, I will give you something. So I want to see if you can combine what we learned yesterday. I'll read it out loud to you again. The number of times the variable repeats becomes the, Tim Gann. Not the answer I'm looking for. Tim. Mike. Coefficient. That's right. It becomes the coefficient. See, I wanted you to infiltrate that language of math. Go get top Jorvis, Mr. Man. Very good. It becomes the coefficient. So like I did yesterday, I'm going to stop along the way before we move on. Are you okay with this? I'm not asking you to master it, but are you starting to understand it? Do you see the difference between multiplication from yesterday? Why x times x times x is not the same as x plus x plus x. Do you see that? Because x to the third is not the same as 3x. Are you okay with that? Example 2 is just like example 1. The only difference is you get to pick the number you want to substitute. And then I'll call on somebody because I can't do 26 different numbers over here. But remember, think small. When you think small, though, don't use 1. I always like to start with 2 because sometimes 1 could throw you a curveball and it looks like something might be right and it may not be. So who's got a good number for me? Better not be 3.164, Mr. Stroll.
3.4.
What, you went with 5? All right, you're a wild man. Let's do 5.
Oh my God.
5 is reasonable. Yep, gotta count. Gotta make sure I'm careful too. All right, Tim, what do you get? You add all that together? All right, good. Fast forward, next page. When you combine like terms now with addition, what becomes your new equivalent expression? You got it, 5y. Remember, coefficient always goes first. What are you going to sub in for y? All right, that's the variable you pick. Remember, this is the variable, this is the number you pick. Make that little annotation. And this here, I'll do it in a different color, is the number of times it repeats. I'll just put down repeats. Okay, a little mental annotation there, or a written annotation. And then we'll substitute it in. And you can see right away it's going to work. So you could do 5 times 5 in your head. Yeah. Okay? So far, so good?
Yeah.
Not appropriate. Okay, now we got to negotiate that little who's you on. Same thing. What we'll do is we can substitute in. They want us to substitute any value. Let's do 2. 2 is our friend.
Yeah, that's all. That's what I did.
Okay, 2 plus 2 plus 2. Then what? Minus 2. And then another plus 2. This is why we do order of operations in lesson 2, because you got to know what do you do first. Yeah, you're going to do this all from left to right. Okay, which you can do in your head. I'm not going to make you underline each step in this case. As you'll see when it gets a little bit more advanced, I'm going to have you do it. After you substitute, you'll have to go through your underlining. But for this, we can do it in our head. What's 2 plus 2? 4 plus 2. 6 minus 2. 4 plus 2. All right, lock it down. Okay, so then it kind of does a little mini leap here, and it kind of asks you, without me telling you, what do you think the combined term will be? Because you can't go with straighted repeated here because you got a little minus sign in there. So what do you think? Okay, try it. Come on, you're a smart kid. You could do it. He's very smart. What do you think, Jake? And if you need help, I'll walk you through it. You want me to walk you through it? All right, ready? I want you to make believe that the second part from the minus sign, I'm going to block it out as not here. If it was n plus n plus n, what do you have? You're not multiplying. You're adding. Can't do n times n times n would be n cubed, but not n plus n plus n. So, do you want to help him out? Nick. Okay, so I have 3n, right, to start without even looking at this. Now, Nick, take away an n, what do you got? Add an n back in, what do you have? 3n is our equivalent expression. How do I prove to see if it's right? Chris? Right, what was the value that we chose in part A? What do you get, Chris? We now know we have created an equivalent expression that's equal to n plus n plus n minus n plus n. Let's see if we can get through one more example before the break. Okay, now more than ever you want to kind of think small when we substitute in. 2. Substitute it in, but watch what we do. 3. Use the parentheses to substitute. That's going to mean to multiply. Take a look and make sure you've written it this way. Now listen, we're up against the bell. I don't want to rush this because here we do have to incorporate Pemdas with this. So we'll pick this up where we left off in period 3. Okay? Left off. When you now do this, be conscious of your order of operations. What do you have to do first here? Yeah. Okay, but in our parentheses, technically the parentheses is a substitution. So what operation is happening between the 3 and the 2? So we got to do the multiplication before we do the addition subtraction. You are allowed to do multiplication for both of them in the same step. You are, and I think I mentioned that briefly when we did lesson 2, that if there is multiplication in the same step, you can do it in one step as long as you do it left to right. Hidden buyers 3 times 2. 4 times 2, 8. And then I'm just going to bring everything else down. My plus sign, my minus 2, and my plus 2. And now we're up to addition subtraction. They all are equal and who what gets done first. But you got to do it from left to right. So let's just do 6 plus 8 in our heads. What do you get? 14 minus 2. 12 plus 2. 14 becomes our answer. Now we've got to combine it. But before we do that, close your books for a minute, or just turn it face down so you know where you are. I kind of want to just recap something with you. X plus x becomes what when we combine like terms? NOS.
3x.
Everybody agree? 3x? What about this? I'm not going to read it out loud to you, but count them up. Joe. Everybody agree 5s? Alright. Now what if I ask you to do this? I'm going to give it to you as multiplication. I want you to expand it and give it to me as repeated addition. Because I want you to be able to go both ways. It's going to help you. Aiden. Okay, great. And one more. What about 8n? Gia. So you repeated it 8 times, right? So now if you go back to, now open up that book. To this expression. Just look at the 3m. What is 3m as repeated addition? Forget about everything else. Just the 3m is what, Matt? How many of those are there? All right, I've got 3. Use your fingers. Your fingers will help you. I've got 3. I'm going to add how many more m's? I'm going to add 4 more. How many do I have now if I add 3 plus 4 m's? I now have 7, right? Use my fingers here. I got 7. But then what am I going to do? Chris? Not yet, because I still have more here. I got 7 up to this point. I have 3 m's. I'm adding 4 m's. I've got 7, but I'm not done yet. What do I got to do? Glooch. I got to take one of them away. That leaves with me how many? Then what do I got to do? Got to add it right back in again. So how many, after I've combined everything together, how many do I have? 7m. Let's see if it works. What should my answer be according to my last example? When you added all those m's together, what'd you get? I should get 14 is my answer, right? What do I substitute in for m? We prove by substitution, always. We plug in a 2. That's what we did last time, and what do you get? And it works. So my new equivalent expression for that big long one is now 7m. I want to make sure you get it before I move on. I find that adding and subtracting like terms is more difficult for students than multiplying. So I may have to slow it down a little bit, especially when you start doing these exercises. It can get a little hairy.
Okay.
All right, let's take it slow. When we do addition subtraction, I don't care about alphabetical order anymore, because it's just going to confuse you. I don't care about it. I just want you to get it right. Multiplication, if you can remember, great. I'm not going to take off points if you're out of order. But definitely for addition subtraction, don't worry about it. I think it's easier if you forget about it. Just do it in the order in which it appears, as you'll see. All right, we'll start you off slow. How many R's all together? This is what we call repeated addition. Combine like terms, we're going to now make a new expression using multiplication. Okay. Raise your hand if you agree, 4R. If you want, you can kind of do a mental check. 2 plus 2 plus 2 plus 2 is 2 plus 2 plus 2 plus 2. Do a mental check. Always check it. What do you get? 4 times 2. All right, so we're good. Coefficients 4, variables are. Okay? All right, a little bit harder. Remember what this really is. S2S is S plus S, right? How many S's do I have at the very beginning? I got 2. I'm going to add 1, because remember there's an invisible coefficient before that, right? That's really 1S. Now how many do I have? You can cross it out if you do it. I got how many?
3.
Got 3. I'm going to add how many more?
2. 3.
I've got 3. These are done. How many more am I adding?
5.
Total?
8.
8. 8. And then what am I going to do? Subtract how many? What do I got? Coefficient is. Variable is. All right. How many m's to start? Say it out loud. It's okay. I got 3. How many am I taking away?
2.
I got 1. Add 1. Add
4. 7. 6. Oops.
And then what in my last step?
Just four.
No, I have total.
Four.
Good? Don't go ahead. This becomes the leap. Because you really need to know what you're doing when you're combining terms here. So let me kind of just, hopefully this will make sense. First, before you do anything, what do you notice? How is 4 different than anything that we've done in this on this part of lesson 6? What do you see that's different? And you have more than one variable, okay? What you can't do is combine all of the variables together like you do with multiplication and multiply your and add up all your coefficients. You can't do that. What I think helps is to expand it out. How many Q's do I have?
2.
I'm going to write my Q's right above it. Do that. I'm serious. Do that. And then cross it out. Oh, and don't forget the little plus sign. You're going to write it. So I've got Q plus Q. That takes care of what Q. That takes care of your 2Q. Okay? Now ready? What do I do with this plus sign? If it's still here, I'm not going to get rid of it. I'm just going to put it up here. So I just look what I said. I took my 2Q, made it Q plus Q, and just move my plus sign up. Are we okay with that? Okay, then I've got 3 G's. So I'm adding G plus G plus G. Are we okay with that? Cross it out. What do I do with that?
Add another Q.
Bring it up.
And then cross it out.
See what I did?
Plus Q to minus Q. With Q.
See what I did?
Plus Q to minus Q.
If I go and rewrite this next year, I got to choose something other than Q's and G's because they look so similar. I'll go with X's and Y's because it's confusing, but I've expanded everything out, and I think it's now easier to say. I really do. Let's collect all the G's together. How many total G's do you have? Let's start with Q's. How many total Q's do you have? Well, let's do it. We have 1 Q. Adding another one, I got 2 Q's. That's a G. That's a G. That's a G. That's a Q. 3 Q's. Anything else with Q? No, right? Write down 3 Q. Before I go any further, do you see how we got to that 3 Q? Yes. Now do the G's. How many G's? 1. Add another. 2. Add another. 3. Take away 1. How many do I have? Positive or negative? I don't have it. I have 2 positive G's, right? Uh-oh. I see blank stares.
Blank space.
We'll practice it. You have to practice it. Yeah.
Okay.
Nope. You can't combine it anymore. You're done. This is separate from this. You can only take all of your Q's and combine it together, and take all of your G's and combine it together, but you can't mishmash it all together. That's it. You can't combine it anymore. You have 2 coefficients. You have a 3 and a 2, and a Q and a G. That's the leap right there. We'll practice it. Let's do another one together. First, how many variables do you see in 5? How many different letters do you see? Joe? how many different letters? Just look at the letters. Look at your variables. What do you have? All right, we have an F. I'm going to put it here. What else? We have an X. We have Y. How many different letters do you see? I see an M. I see an X. I see a Y. Do I see any other letters? What letter? An N. So I now know, remember, I've got to combine all my M's. Then I'm going to combine all my X's. Then all my Y's. And then all my N's. Well, this is why I don't care about alphabetical order. Yeah, Jay? All right, let's do it together. That's good. So let's start with M's. I start with how many M's? I've got 10. Cross it out. Now, look through. Do you see any more M's? Right there, I'm adding 2 more. How many total so far? Any more? Write it down. I've got 12 M. My M's are done. Okay, let's do the X's. I've got 4 X's. Cross it out. Any more? Getting hung up on semantics. There are additional X's, but she's right. We have 4, but what do we have to do to what we have? Subtract how many? I've got a -2 here. Cross it out, and now I have 2 remaining. Anything else? Plus 2x. The X's are done. Now it gets even more confusing because I have a Y here, but it's got a there's a 3Y, and I've got a -Y. So how many after you've done 3 take? Remember, there's a little invisible coefficient here. 3 take away 1 is 2 plus 2Y. Gone and gone. I got 1N plus that. What you have to kind of get into your head, unlike with multiplication, you can't add all the coefficients together for each one. You have to keep them separate. And if you don't understand why, I just will tell you that's just the way it is. These are not like terms. You can't combine them. You can do it with multiplication. You can't do it with addition. That's the leap that makes 6 complicated, is what's going to happen if we don't practice it enough. You will get confused of what to do when you're multiplying compared to what you're going to do when you add and subtract. And I actually want to kind of stop there for today and do marker boards, because I want to practice it. All right? That's the only way to learn it, is to practice it. No homework. No homework.